Hello Internet, my name is Quinn and this is Blondihacks. This is Lathe Skills, a series of quick videos on getting started in machining. This is part 15, parting. Oh yes, the one everyone's been waiting for. Parting is such sweet sorrow and every beginner is terrified of it and every beginner struggles with it. But I'm here to say you can do it even on small machines, and I'm going to show you how right now. Let's start with a quick note on safety. Parting is the one operation where I go ahead and wear a face shield because the failure mode for parting is generally the blade shattering, and that's not something I like to have in the vicinity of my face. So this is the one time I throw this guy on when I'm using the lathe. And the second thing is your e-stop button. If you're new to machining, you may have never hit this guy. So I think like a fire drill, you want to do it just so that you're comfortable doing it in case you ever actually need to. You'll know what that feels like. So I encourage you to just fire up the machine and give that guy a slap so you know how it feels. And you're comfortable with shooting your arm over there, because again, when things go wrong in parting, they go wrong fast and things are going to bind up, and you're going to want to just be comfortable giving that guy a slap when you need to. So give yourself a little e-stop drill. Wait a minute, if parting is so difficult, why do we even bother? I mean, it's usually the last operation you do on your part, so it's coming out of the lathe anyway, so why don't we just go cut it off on a bandsaw or something like that? Well, the reason that we do it is that it can often save you a lot of time. For example, if you are making multiples of a part on a single piece of stock, often what you'll do is you'll chuck up the stock like this, and the excess is going in through the spindle bore, and you can make your part and then part it off and just pull the stock out, make another one, part it off, and you can make a lot of similar parts very quickly that way. Another reason is that once you get good at parting, it can often save you having to face off the back sides of your part, because a good parting tool operation will actually leave you a finish equivalent to what facing would give you, which can be very efficient. And the other reason is that oftentimes if you're making very skinny parts, like let's say you need a bunch of bushings or washers, you might drill a hole down the center of your stock and then grab your parting tool and just part them off. And the resulting parts are too skinny to re-chuck and face off the back sides of them. So the parting tool allows you to lop off a whole bunch of washers or bushings in one operation and not have to worry about how to hold those really skinny parts for a second setup. And parting is just fun and cool. Once you get the hang of it, you'll actually enjoy doing it, and it won't terrify you quite so much. But it's still the scariest operation. Now, if you spent any time in machinist forums, you know that one of the most common threads is "help me with parting," and it's the one operation that I think sows fear and dread into every beginning machinist. So the question is, why is it so difficult? Well, first of all, it's not super difficult, but it is more difficult than most other lathe operations. And for the simple reason that it's the operation that asks the most of the machine. It's got the thinnest margins for error. So it's high tool pressure, and it's demanding of rigidity, and there isn't a lot of wiggle room anywhere. You know, with most other lathe operations, if your tool post angle isn't quite right, or your speeds and feeds aren't quite right, or your tool's a little dull or whatever, you get away with it and it's fine, and you don't really know that maybe you're making the mistake. But with parting, well, that's where we separate the women from the girls, because if you're doing anything wrong, the machine will let you know, usually by chattering and often by grabbing the blade and shattering it into the face mask that you are, of course, wearing. So that's really the key to parting, is that the devil is in the details, and you have to do everything right to have good luck with it. So what is it about parting that makes it so demanding that all of your machining parameters have to be perfect or it doesn't work? Well, look at this blade here. It's got width. This is not a single point cutting tool. This is a form tool. And form tools are really where the rubber hits the road on rigidity and cutting fluid and squareness and everything else. So keep that in mind. The parting tool is a forming operation, not a single point cutting tool. And forming tools are best left to the woodworkers. Here in the machine shop, we're civilized and we prefer single point cutting tools. Now, I'm by no means an expert machinist, but I am going to show you everything that I know about parting, and I think a lot of the common mistakes that beginners make and the reasons people don't have good luck with this operation. And just to make this point, on this small benchtop machine here, I regularly slice chunks off of this 3-inch steel round bar, and I have good luck with it, and you can too. Now on to the tools of the trade. Parting tools basically come in two forms. You've got your traditional ground style of parting tool, which is just ground from a high-speed steel blank like any other lathe tool. And then you've got parting blades, and these guys come in high-speed steel forms and also in carbide insert forms. Starting with the traditional ground parting tool, one of the advantages of this guy is that you get a nice amount of thickness here, so they're nice and rigid. And the other nice thing about them is it's easy to grind profiles into them, so you can control the rake on the front edge here, and you can grind a top rake into it, which gives you a nice rake behind the cutting edge, which makes this guy really good at starting chips, which a lot of parting tools are not. And of course, it's also nice that these guys fit into standard tool holders. And they're inexpensive, and you can make one yourself out of any high-speed steel tool bit stock that you have lying around. And of course, the main disadvantage to these guys is that they generally don't go very deep, so we don't have a lot of reach with this guy. But for many parting operations, this guy is great. And these tools are also really great for non-parting operations. They're great for cutting O-ring grooves or giving yourself clearance when single point cutting threads up to a shoulder, those types of things. So a very useful tool generally. On to the high-speed steel parting blades now. This is my favorite kind. This is the T-shaped blade. You can see that the top edge is a little bit wider, and then there's a thinner body underneath. And this gives you clearance down the sides of your cut, which I find very helpful when parting. And like most parting blades, this guy lives in a parting tool holder, and we'll talk a little bit more about these guys in a second. Now these guys come in a lot of different thicknesses, and the thickness is generally a trade-off between tool pressure and lateral rigidity. This is a 1/16 blade, and I like the thin ones because I have a small machine, and I think it is happier with these thin blades. But the downside to this is you have to be wary of situations where you're going to have lateral forces that are going to want to flex this blade sideways. And next we have the flat style of high-speed steel parting blade, and these guys have a tapered profile on them. So if we look at the end here, you can see that it's kind of a trapezoid, and so it's got tapered sides, which gives you that clearance down the sides of the material when you're in the middle of the part operation, which is nice. And these guys also have a top rake to them, which helps with chip formation, and so these guys can be a good option as well. And last but not least, we have the carbide insert style of parting tool. And these guys have a holder that's designed to go into a traditional parting blade tool holder, and then it's got this replaceable insert at the top. And this insert has generally a pretty sophisticated geometry. In addition to top rake there, it's got some taper to the sides, and you can see it's even got a relief in the center there, which helps with chip formation and braking. So these guys are pretty sophisticated, and many machinists swear by these. Like any type of carbide though, it does ask more of your lathe. So I think for a lot of smaller machines and hobbyist machines, carbide may give you more trouble than good old-fashioned high-speed steel. So when you're starting out and you want to try your hand at parting, you might be wondering, well, which one of these should I try? Well, you can tell by which ones I've blessed with tool holders, the ones that are my go-tos. I'm a big fan of this guy for, not actually for parting, but for various types of forming, grooving type operations. And then for actual parting work, I really like the T-shaped blades. But parting tool selection is one of those things that machinists will die on a hill over, and if you go looking for advice in any online forum, you will be inundated with very, let's say, engaged threads about which one is best and why no other opinions could possibly be correct. So what I would encourage you to do is start with one and try it out, and if you don't like it, then try the others, and you will find one that works best for you. Okay, let's talk about how you hold these things in your tool post. Well, like I said earlier, the traditional parting tool can live in any old standard tool bit holder that you've got lying around, but the parting blades require a dedicated holder, and these guys all work pretty much the same. They've got a clamp up here that pulls back and down with a single screw back here to lock the blade in place, and this also allows you to slide the blade in and out for different depths. The other thing these parting blade tool holders do is give you the correct back rake on that blade. Because the tops of these blades are flat, you don't have a rake cut behind the cutting edge like you do on the traditional parting tool or the carbide insert tool. The blade holder is doing that for you. So that's the other reason that these guys are important. Now the gotcha with these guys is that the registration surface upon which the blade sits is always flat, and the parting blades almost never are. So depending on which type of blade you are using, you need a couple of tricks to get the best performance and best results out of your parting blade. In the case of the T-shaped blade, because of course the blade is T-shaped, hence the name, the clearance areas here are going to cause the blade to sit crooked if you just clamp it flush against this back here. So some people will put this guy in the mill and actually just grind a slot for clearance for the T area at the top. But what I like to do is actually just put a little shim back there. A slice of aluminum can works really good, just enough to shim it up so that the surface sitting against here is flat and is holding the blade vertically so that the clearance areas on the skinny part of the T can do what they are intended to do. And then similarly, if you're using one of these tapered blades, I like to put a little shim down here at the base of the blade so that the blade itself is held vertically on its center line, and the tapered areas are tapered inward like they're supposed to on both sides to give you the clearance that you need for your parting. And for the carbide insert blades, of course, they are very simple because all the fancy geometry is confined to the insert. So these guys are just a flat piece of ground steel to give this guy a little home in the sky, and all he has to do is sit flat in this holder and Bob's your uncle. Okay, let's talk setup. Now, the most important part of your parting setup is rigidity, and of course that's always desirable in machining setups, but parting, there's just no wiggle room here. Your rigidity has to be absolutely on fleek or you will not have good luck. So we'll work our way top down here. Obviously your tool post has to be tight. If you're not always tightening your tool post, then you are definitely going to die, so please tighten your tool post. Next is your compound. Take a good look at your compound. Make sure that it's not overhanging its slide over here, because that's a common source of rigidity loss. And lock your compound up good and tight. If you don't have a compound lock, you can probably add one just by tapping a hole in the side. If there's no way to do that, tighten up the gib adjusters on it. These guys, you don't use your compound that much. So there's no reason for this guy to be super easy to move. And for smaller machines, a lot of people will actually just remove the compound completely and add a riser to your tool post. That's something to consider as well. So make sure your compound is locked up good and tight. Working our way down to the cross slide now. This is the only slide that actually needs to move for this operation, so you can't tighten it up completely, but make sure this guy is properly adjusted. If your gibs are not really well adjusted and there's any more movement here than there should be, then make sure that you remedy that before you try to do any parting. And for a little extra liquid courage, I like to just snug up the lock a little bit. Just don't lock it, but a little light pressure on the gibs just gives you a little extra rigidity comfort there. And to the bottom of our slide stack, of course, is the carriage. This guy does not need to move during the parting operation, so lock that guy down, leave it locked, you're good to go. Before you begin, you want to make sure your parting blade is nice and sharp. Again, this really matters for parting. So the nice thing about these parting blades is that you can just keep grinding the ends off of them to keep them sharp. And you can give the top a little love too, just to make sure there's no burr or rolled over edge on there. And once this guy is razor sharp to the touch, you are ready to go. You also want to make sure that the front edge of these guys is perfectly square. So if you've got any kind of like an angle on this, what happens is the parting blade, these thin blades, are going to tend to push themselves laterally as they start the cut. And that's going to cause binding as the blade gets deeper into the cut. And that lateral movement and binding is what causes these blades to shatter and generally ruin your day. So make sure that while you're sharpening it, you're really keeping that front edge perfectly square. Next, we want to get our blade depth set correctly. And this is another critical thing that I think a lot of beginners get wrong. You need as little stick out on this blade as possible. And this is very important. So because of the relief angle that's cut on the fronts of these holders, you can get quite close to a round piece. So get basically as close to the stock as you feel comfortable doing, and then bring this blade in until it's just at the center like that. And that way you've got the absolute least amount of stick out on that blade that you can get away with and still get your operation done. Now, if you're turning very large stock, you can start with the blade pushed in like this, and then once you get in a little deeper, you can stop and extend the blade out a little bit and keep going, and that will maximize your rigidity throughout a large parting operation. All right, next up is setting your tool height for the parting blade, and this is another one of those areas where for other types of lathe operations, if you're not dead perfect, you'll get away with it. It'll still work. But with parting, there's really no room for error here. So your tool height has to be dead nuts on. And the best way to do that is to flip your tool post around so it's facing your tailstock, put a good center in your tailstock, and then bring this guy up here and make sure that the top surface of that blade is dead nuts on the very point of that tailstock. Now when you're checking this height, make sure that your tool post is tight and the tool holder is tight in the tool post, and that because all of those things can actually affect the height of the tool post. So before you take your final reading, as it were, tighten everything down, take a look. If it's a little too high or a little too low, then you can loosen it, move it up a little bit, tighten it down, check it again. Now if you want to err one way or the other when setting that tool height, err a hair on the high side, because that way when the tool pressure drives this blade down, it's going to just put it more on center, which is okay. When the blade is too high, the worst that happens is it doesn't cut very well. If the blade is too low, what can happen is the tool pressure drives the blade down, which if it gets below the center line of the stock, you're on the underside of this curve now. And what can happen is, remember this stock is spinning this way, so what can happen is the stock can climb right up on top of that blade, and that's when the really bad things happen. That's when the blades shatter and machine jams up, belts slip, gear teeth break, etc., etc. So yeah, if you have to err one way or the other, err just a hair on the high side with this guy. Next up is squareness of your tool. Again, for other lathe operations, this doesn't matter very much, but for parting, it's critical that this tool be extremely square to your work, because otherwise, as this blade goes into the work, it's going to become crooked with the cut that it's making, and it's going to start to bind up. And binding up is what causes all problems in parting. So your tool post has to be absolutely square. There's lots of good ways to do that. You can snuggle it up to the face of your tailstock quill, which of course is machined and a true surface. What I like to do is put a machinist block on the face of my chuck and just give that guy the right angle, and then just bring this in, and with the tool post loose, it'll just snuggle itself up into square, and then snuggle it up like that, remove that block, and then put the hurt on it. And we're good to go. If you faced off the work, you can also use the end of that, because it's in principle as square as anything else is on the machine now. But you can also use the face of the jaws if the stock isn't in there yet, or there's other ways to do it. But just make sure that that tool post is dead on square and good and tight. Next up is to choose your parting location, and this is also important. First and foremost, you want to work as close to the chuck as you absolutely can and still feel comfortable. The closer you are to this chuck, the more rigid the whole setup is. And again, this is an area where when you're turning, you might be able to work out here and get away with it. When you're parting, you absolutely have to be up in nice and close to this chuck. The best way to be comfortable with that is to simply bring it in as close as you can and spin the chuck by hand. And if it's not hitting anything, then lock the carriage down right there, and it's not going to move. You're not going to hit that chuck. If you're not hitting the chuck now and the carriage is locked, you won't hit that chuck while you're moving. Now, one thing to watch out for, though, is that there may be parts of the tool holder or things back here that stick out further than the blade does. So make sure that you're not going to get into trouble when this blade is in deeper and all this stuff is now closer to those chuck jaws. And an easy way to check for that is to just throw your machinist scale on the outside of your tool holder and just bring it in. And again, you can give your chuck a little spin there, and that'll tell you for sure that nothing's going to hit. Next up is cutting fluid. This is another area where with other lathe operations, you might get away with not using it or not using it as much as you should or whatever. Not so with parting. You pretty much can't use too much of this stuff when you're parting. You want to keep the cutting area just constantly soaked as you're going. So I like to just use it straight from the bottle and just kind of hold it over the parting line and just drip it in there pretty continuously, at least every few seconds. And yeah, keep that area nice and lubricated. So this is doing a bunch of things for you. It's helping to carry chips out of that cut, which is important with parting because you're creating a very small space and the chips have trouble clearing themselves out of there. So this helps with that. It's also making sure you have good chip action because parting blades don't make great chips, not like a regular single point tool does. So this is going to help with that. It's going to keep your temperatures down in the part, which is important when you're doing something like a big piece of steel. You don't want anything expanding because when things expand, the work might tighten on the blade or the blade might tighten in the slot. You don't want any of that. And it's also very importantly lubricating the sides of the parting area. Because again, the blade is going in, and if it's going in pretty deep, now the sides of that blade are rubbing on the stock, And so it needs lubrication in order to prevent anything from binding or snagging, or if unfortunately your blade starts to wander a little crooked or whatever, lubrication is going to save you there, because if anything gets crooked or binds up or snags, that's when blades shatter, and yeah, that's when things go wrong. So cutting fluid, definitely not optional, and the more the better. All right, let's talk feeds and speeds. Now this is pretty straightforward actually for when you're learning to part. Run your machine as slow as it will go. When you are first learning, especially in steel, there is just no reason to do this fast. So I always start, especially on a larger diameter part, as slow as the machine will go. And if it doesn't seem to be forming good chips, then I'll ease it up a little bit. And as I get closer to the center, I will ease it up a little bit more. But when I'm parting steel, I probably never get above 150 RPM. And I think the lowest this machine will go is 45. So just start slow and work your way up from there. All the parting drama happens if you're going too fast. So slow and low, that's the way to go for parting. Now down here on the feeds, I strongly recommend when you're learning parting off to feed by hand, because the feel is very important. Parting tools are not great at starting a chip, but they are very good at keeping a chip going. So you'll feel it when you have the feed just right, where once you've got it started, you'll get these ribbon-shaped chips coming out of the parting line, and then you just keep easing in at that same pressure, keep that pressure constant, and it'll feel good. If you start to feel the cut kind of bouncing, or the machine starting to labor intermittently, that's when you know you don't have your feed quite right. You're not keeping up with that continuous spiral chip that you want to make as the parting tool goes in. A lot of machinists will swear that power cross feed is the way to go for parting. I personally don't like to do that. I like to have the option to quickly ease it out and stop the cut if I hear something I don't like or I feel something I don't like. But if you're feeling brave, go ahead and try power cross feed. I think the advantage of it is that it gives you that nice slow, even, constant pressure automatically. And that constant pressure is really what you want when parting. You don't want that tool to have to be losing that chip and starting a new one, and introducing opportunities for chatter, things like that. So that even pressure is really what you want. And if you've got a good power cross feed that'll go slow enough and gives you good results, then go for it. But like I say, personally, I like to feed by hand, because that feel and that sound and having the option to abort at will is something that I like. All right, less talking, more parting. That was a lot of explanation and a lot of setup, but it really does matter for parting. So let's actually do the deed here. So I'm going to come in here, lots of cutting fluid, got all my slides locked, going to start my machine nice and slow. I know that my chuck is clear of that tool post, so starting at 60 RPM here, and I'm just going to ease it into the work. And here we go. You can see that chip starting to form. And you can listen to the machine, and you want to kind of hear a nice even load on there. Just don't be in a hurry. And if you look closely there, you can see that kind of ribbon-shaped chip coming off of there. That's really what you want. You want those ribbons. Once you get that nice ribbon, you've got the pressure right. So just keep it going. And just keep that fluid in there. The better your technique is here as well, the better your surface finish is going to be from the parting operation, which is one of the main reasons that we're doing this and not just taking it to the bandsaw. You can also back it out occasionally to clear the chips if your slot is getting deep and the parting blade it looks like it's having trouble clearing the chips, then just give it a little help. Because our carriage is locked, there's no drama in leaving that slot and coming back in. It'll come back right where it was. Now getting that chip started again is kind of the exciting moment, so go in nice and easy till you find that surface again. And there we go, it'll pick up that ribbon chip again. And away you go. You can see as that slot gets deep, this is right around the time where if our blade wasn't perfectly straight, or if something was binding, or if the blade was crooked in that tool holder because we didn't have that shim behind the T-slot, all those little areas that we talked about, this is right around where you find out if any of them aren't right. And I know where my E-stop button is. And you can see the work that it has to do to clear those ribbon chips, so it never hurts to just give it a little help, because you really don't want those chips to pile up in there. That's a source of trouble. Just when you come back in, again, just ease it in real easy. If you jam it in there, it's going to grab, and again, that work is going to climb up on the parting blade and chaos ensues. But if you ease in there, it'll just pick up that ribbon chip right where you left it. And I'm doing this in real time so you get a sense of the pace of it. Just not in a hurry. If I was on a production line, I'd want to be doing this a lot faster, higher spindle speed, more aggressive, but I'm at home in my hobby shop. I'm in no hurry, and I do not relish picking parting blade shards out of my face. Now, as you get close to the center here, I'm going to ease the spindle speed up a little bit, because the blade will start to push and not cut if the surface speed gets too low. So a little more surface speed really helps. So we're up to 110, 120 RPM right there. Now when you get close to the center, what's going to happen is at some point that little tiny nub in there is no longer structurally sound enough to hold the weight of that part off the end, and it's just going to break off and fall. So if it's a part you care about, stick a piece of cardboard under there or something to catch it. I don't like to stick my hand in there and grab it. Just put something for it to fall on so it doesn't land in the chip tray or get dinged up on your ways. But yeah, in this case, I'm actually just going to let it fall, because the camera mount is in the way there, and I can't safely get in there. So I'm just going to let it go, pick it out of the chip tray like a chump. And you can feel when it's just about done. We're just turning a toothpick right now. Metal toothpick, like civilized machinists. And there she goes. All right, you can see that we got quite a nice finish on there. It's not perfect, but for a parting tool, it's pretty good. Now, you're pretty much always going to end up with this little nub on there. So if you need to get rid of that, you can either chuck it back up and face it off, or just hit it with a little 400 grit emery paper, and you can take that little guy right off of there. All right, but real talk now. Even with all of those tips, parting is just not always going to go well. The bottom line is there are some machines that aren't great at it. You know, I told you at the top of the show here that I was going to show you how to part even on a small bench top machine like this. But I'm not going to sit here and tell you that you're going to be able to part steel easily on a 7x14, you know, Chinese mini lathe. There are some machines that just can't do this, even some big ones. You know, it's asking a lot of the rigidity of the machine. It's asking a lot of the bearings and the spindle. So if everything isn't perfect in the machine, you just may not have good luck with it. But that's okay. There's no shame in that. There's lots of good alternatives to parting. So let's talk about a couple of those. So first and foremost, of course, is just take the part out and take it over to the bandsaw. That's you know, a very easy option, and like I said earlier, it's you know, you're probably taking the part out of the machine anyway, so you know, it's your last operation. You have to flip it around to face off the end anyway, so just take it out, take it over to the bandsaw. This isn't a contest to see who's the best machinist. You know, there's no shame in just in not being able to part on your machine. Just use the bandsaw. Now, if you don't have room for a bandsaw, they do take quite a bit of room. There's our good old friend the hacksaw is a perfectly good alternative. The one thing I would say is don't use the hacksaw on the stock while it's in the lathe. I know that is tempting, but the thing is, you know, hacksaws tend to jump out of the cut while you're going, and at the end of the cut they tend to drop down, and you're very likely to ding your ways or ding some other part of the chuck jaws or the machine while using a hacksaw. And you know, personally, I think that it's probably also hard on the spindle bearings. Your spindle bearings are not a bench vise. They are not designed to be used for whatever kind of stock holding jobs you might have. For me, this calculus is simple. The spindle bearings in my lathe are the most valuable thing in my machine shop. Everything that I do, the precision of everything I make, depends on those bearings being perfect. So why would I do anything that might be abusive to them? So show your spindle bearings some love. Take the part out of the chuck, put it in the bench vise where it belongs before you use this guy. If you insist on doing it, definitely do not do it while the spindle is running. That is a surefire way to end your day by picking a hacksaw out of your spleen. And all of those things I just said about the regular hacksaw go times 10 for the portabands. These portable bandsaws are probably the greatest tool invented in our generation. They are fantastic, but yeah, the temptation will be even stronger to use it on the lathe, and the damage will be even worse when you do. So yeah, keep this guy away from the lathe. but these are amazing. And a little love on the emery paper, and you'd never know which end is parted. Well, at least from a distance if you squint a little bit. So that was a parting demo on steel, but when you're first learning parting, I would recommend starting with brass. Brass is going to be a lot more forgiving, and it's just much lower drama if things go wrong. So start out on brass, and once you get comfortable with that, then you can move up to steel. And similar to other machining, I recommend trying on 12L14 free machining steel first. It's a lot more forgiving with parting as with everything else, and you'll have much better luck with that learning curve. So that is parting in a nutshell. I hope you found this useful. Please consider supporting me on Patreon. There's a link right there on the screen, and we will see you next time. Thanks for watching.